y equals cotangent of 2 over x. It says to let u be 2 over x, but that's just telling you, we'll get into some, oh, thank you. All right, so y'all ready? All right, derivative here. We're going to do derivative of the outside, right? So what's the derivative of cotangent? Get out your little handy dandy sheet. I don't know cotangent off the top of my head. Negative cosecant squared x, right? So I've got 5. That's just a coefficient in front, so it's going to stay. Times negative cosecant squared 2 over x. But now I have to take the derivative of the inside, right? So the question is, if this is what's on the inside, what's the derivative of 2 over x? Which is really the derivative of 2x negative 1. That might help you some, right? So what is the derivative of this? Negative 2 x to the negative 2. Are y'all okay there? So now I can bring this around front. I've got 2 negatives multiplied together. I'm just going to bit those away. And I have 10 over x squared cosecant squared 2 over x. That's it. Tell me where you're struggling. Knowing what to chain, or did you try to product rule? Or you just looked at it and said, I don't even know where to start? Everybody okay on that one? Give me another one. 10 and 15. Do 10 first. In order. S equals t cosine pi minus 4t. Because there's a variable this time, here I'm going to have to do product rule, right? That's not just a coefficient, just a numerical coefficient. It's actually a variable, so I'm going to have to do product rule. So derivative here is that all it asks me is the object moves along so that it's position, so this is find the velocity. Velocity is derivative of position, of course. All right, so derivative of the first would be 1 times the second plus the first times the derivative of the second. This is where I'm going to get bogged down a little bit. Derivative of cosine is negative sine, but I have to leave everything alone here, right? And then I multiply by the derivative of the inside, so from the outside in. So what's the derivative of pi minus 4t? Negative 4. This doesn't go inside this parentheses with this. This is saying take the sine of this value. This is just multiplied here. So I end up with cosine pi minus 4t. Again, I have 2 negatives. I'm going to get rid of those. I'm going to bring the 4 around front with the t and say plus 4t sine pi minus 4t. Y'all okay there? So 15 and 13. Y equals x plus the square root of x. Anytime you use the power rule, which I'm going to do here, I'm going to need to go back and chain it and do whatever's inside, whatever's hooked with that. Are you cold, Giselle? What? I'm sorry. All right, so I'm gonna do power rule first. Everybody okay there? But then I need to chain it, so I need the derivative of the inside. What's the derivative of x? 1. What's the derivative of the square root of x? Y'all okay with that? That thing, like, all of a sudden, it never does that. All of a sudden, it just started really, like, almost at it again. All right, so I could technically, if I wanted to, I could combine these two parentheses because there's no exponent on the outside here. And I could make this -2 minus x to the -1/2 times I would say yes, since it's the way it is. Just know how this could manipulate if it was a multiple choice question. Maybe they even do, I don't know how your solutions in the book do. I would imagine something like this. Why is the what? I just distributed the -2 through to this, to both. I don't see an answer to 13 in here. They have the answer to every other one. They have, oh, there it is. Oh, they did way more. Actually, they left it like that, oddly enough. Would I move what now? The -x down? So in this case, because this minus is here, I couldn't move just that x. If the exponent is on the outside of a parentheses, I could move the whole chunk, but I can't move just that x. I could make it -2 minus 1 over the square root of x over, but I can't take it to the whole bottom because it's not being multiplied there. Other questions about that one? Are y'all okay? You don't have to. Just recognize if your answers look like that, it may need a little more manipulation if it's a multiple, because this would be a typical multiple choice type question. And then you said 15? Oh, 15 is good. Sine -5x minus cosine cubed. Remember, this is the same thing as putting the exponent out here. So I'm going to do power, excuse me, I'm going to do power property first. So -5 times the sine -6 of x. But that was only the power, right? Now I need to do the derivative inside. So what's the derivative of sine x? Cosine x. So I'm going to multiply by cosine x. It's a little easier to see if it looks like this, right? Because then I go, okay, well, I do the power, so that's -5 sine x -4 or -6. Now I need to do the derivative of the inside, which is cosine x. So it's a little easier to see if the exponent's outside instead of inside like that. And then same thing with cosine, so -3 cosine squared x, but then I need the derivative of cosine, which is negative sine. And then just clean up the -5. I'm going to actually do, just because I don't like the negative exponent so much, but it's definitely not necessary. Are you making them harder than they are? Or you just didn't know? What else? Everything after that? Okay, 16. Y equals x cubed times 2x minus 5 to the 4th. I see a product rule. Or, well, no, you can't distribute through unless you FOILed this out 4 times, right? Which is what we were doing in the section before. Blech. All right, derivative of the first times the second plus the first. Now here's where it's going to get a little bit harder. I got to do the derivative of all of this. So I'm going to do power rule first, because that's the furthest outside, 4 times 2x minus 5 cubed. Now times derivative of the inside, which is 2. So remember, it's derivative, so this is derivative of the first times the second plus the first times derivative of the second. And so here's my first and my second. You're freezing now, aren't you, Drew? I was hot too, and it's kind of chilly now. I'm just going to put some of these things together. Just be careful when you do that you only combine what you can. Don't start jumping inside that parentheses because it's got that exponent to it. $18, Joe said. Ooh. Looks worse than it is. It really does. Square root's nothing more than an exponent, right? So I'm going to change it just so that you can really see the power rule and the chain rule work. Power first. A half times 4, 2. Leave everything inside alone. Negative 1/2. Now multiply by the derivative of the inside. What's the derivative of secant x? Secant x, tangent x. I'm going to do this. Plus, what's the derivative of tangent? Derivative of tangent x, secant squared x. I'm probably stopping there. To try to do anything else, I mean, I could put this in a radical on the bottom, maybe. But I don't know that I'm doing anything else here up top over square root of. Again, not really necessary. I would probably stop right here if I was here. Not really anything to combine or clean up there. Product rule with the chain. Double chain, maybe. All right, let's see. Derivative. Derivative of the first. So I need to do derivative of sine cubed x. Power first. Times What's the derivative of sine? Cosine. Everybody see what we did there to get that derivative? Again, sometimes it's easier to think about it like this. Instead of sine cubed, to think about it as sine x cubed. That's the derivative of the first, and now I need to multiply it by the second. Y'all okay there? Plus the first times derivative of the second. What's the derivative of tangent? Secant squared. The 4x stays, but now I need to take the derivative of 4x, which is 4. Only thing I would do here really is maybe move that little 4 around to the front. Is it making a little more sense? I see y'all like frantic, right? Like you didn't get it right, or y'all okay? It's hard. Thank you. You didn't do this one. It's okay. I'd rather you not get bogged down and be up all night looking at it, just staring and crying, because a lot of times it's not as hard as what you think it is. And if we can answer the questions the next day. All right, I'm going to do power rule first. So 2 times 1 plus cosine 2x. Now let's do the first, right? But now I need to do the derivative of the inside. So times, derivative of 1 is 0, so it doesn't matter. Derivative of cosine 2x. Negative sine, but I have to leave that 2x alone, right? But now what? Times 2. This was a power rule with a double chain, because I had to take the derivative of 2x. I have to work from the outside in, and I can only do one at a time. Sure. Shy of making this 4 times. There's not much else you can do with that. Because this was negative sine. Or cosine things. What 2? No, that was positive, because that one is just the derivative of this. There was a 2 in front already from the power rule where I did this. Yes, the 2 on the end with the 2 in front. No, I really multiplied. This is like negative 1 sine 2x times 2. So I multiplied 2, negative 1, and 2. Yep. Yep. And not 24? 24 is hard. 21. Power rule first. What now? That's my power rule. Derivative of sine. What's the derivative of sine? Cosine. Everything else, just one derivative at a time. Everything else stays the same. So cosine 3x minus 2. Am I done? Now I take the derivative of the 3x minus 2, which is 3. Yep. Let me write this. Right. So remember outside in. So power rule first, trig function second, and then derivative of the furthest inside last. Does that make more sense? So outside in. So power rule was first, there's power rule. There's my trig, which is just the sine or cosine, and then inside trig. So whatever was in here, I do the derivative on. I could make this 6 sine 3x. There's not much else there. What do you mean? You could or you couldn't? What do you mean beside each other? Like that? No. You have to leave their arguments there. Other questions about that one? Sure. All right, that was 21. Which other one did you say? 23 and 24? Ooh, 23. So let's think about what we're going to do first before we do it. The furthest outside is my power rule. You agree? Then what? Then the derivative of the inside, right? But when I get to the derivative of the inside, I'm going to have to do power rule of cosine, followed by cosine, followed by inside. You see how I'm working from the outside in? I don't know if that helps you with the steps like that to show you, but yes. But within that entire parentheses, I have to do this, this, and this. Okay, power rule first. So 3 times 1 plus cosine squared, which is really cosine 7x squared, right? Just write it a little different, and then it's squared. Now I need to do the derivative inside the parentheses. Derivative of 1 is just 0. So now I need to do the derivative of this. Power rule again, right? Because this is cosine 7x squared. So I need to do 2 cosine 7x. Power, trig, inside trig. That's the power. Now the trig. Derivative of cosine is negative sine. Now inside trig. Then you would do, because it's addition, I can do them as two separate. I don't have any type of so I would do the derivative of that one plus the derivative of the second. I can clean this up just a bit. I can't mess with anything inside here because there's an exponent hooked to it, right? But there's no exponent here, so I can maybe combine the 7. There's a negative here, the 2, and the 3. Negative 1 plus cosine. And then times cosine 7x. I like these, I'm sorry. I know y'all don't, you're looking at them like, oh my gosh. I hate evaluating trig functions. I hate working with trig identities, but I love doing these types of trigs. They're satisfying. What did they do? How much more work is there to do? They do use substitution, don't they? Think that would help y'all? I can show you that. It's a lot of writing. They're just telling you that this is the derivative of, yeah. Seems very redundant. And 24? I see power trig inside here. Does everybody see the same 3? Square root is an exponent, right? So power trig, what's the derivative of tan? And now inside. Be careful, don't let that sit with the 5x here. So 5 over 2 tan 5x negative 3 over 2 secant squared 5x. And that's it. Oh, yes, I'm sorry. Right day. Thinking it was already negative 1. Did y'all get the first cube? Like, y'all got those kind of. So it's just when you throw the power in there that's throwing you. Is that what it is? So if it was that, that makes it harder for you. Now you know. What do I need to do first? Find the derivative, right? So g prime of theta, just got theta in there because these are angle values. Don't let that throw you. If it does, put an x in place of it and roll on. So derivative here, derivative of cosine is, of course, negative sine. 3 theta plus pi. And now chain it. So I have negative 3 sine 3 theta plus pi. That's the derivative. But it asked me to find the derivative at pi over 4. So that means -3 sine 3 times pi over 4 plus pi. I would probably have my unit circle handy as I tried to do this. 3 pi over 4 plus pi. Is that on your unit circle? It is. What's the sign value there? Can't see because I just said. -√2/2. Remember, all your over 4s are square root of 2 over 2. If you can figure out what quadrant it's in, that'll tell you if it's positive or negative. So I got -3 times negative square root of 2 over 2, which would be 3 root 2 over 2. Yep, this is one of the ones on your circuit here. It's come back. What if I wrote it like, I want to make sure you have enough. What if I wrote it as a composite function? In other words, if I said h of x equals f of g of x, what is the derivative of h? You do the outside and leave the inside alone, right? So derivative of the outside, and then you chain it times derivative of the. Okay. Let's see how it goes. You got me here if you need help.